Okay, factoring. Okay, so here's what I would say about factoring. When you're going to factor polynomials, which is what this is all about, okay, you want to follow some general rules, I like to think. So like the first one, I'm always going to look to see if I can take something out of my expression or polynomial or however you want to think of it. That would be the first thing I would do, because that always makes things easier. All right, so then that I look to say, hey, can I take something out of it? I'll go through all these. Take something out of it, maybe I can make it easy. If I can't, the next thing I'm going to look for is a difference of two squares. To see, maybe that's what it is, because if that's what it is, that's the easiest factoring technique, I think. And if that's not it, then I'm going to check to see if it's a trinomial, because I like to factor those two. They're pretty easy to do. And last but not least, I'm going to check to see if it's grouping, which is the one I least like. All right. So those are my techniques or procedures or guidelines or rules or whatever you want to call it for factoring. All right. So I'm going to look to see if I can take something out. I'm going to check for differences of two squares. I'm going to check to see if it's a trinomial, and I'm going to go grouping. All right. So let's take a couple of examples. All of these are factored completely. So I bet most of you are probably really good at factoring. The problem is people lose points because they don't factor it completely. They leave something undone, and that's where the points get lost. Okay, so it's not in the factoring, it's in the factor completely actually. All right, so let's let's pick some out here. Let's go with something like this. 2x cubed minus 8x squared. All right. So we're going to factor this, which means we're going to undistribute or unfoil, in case you might have forgotten what factor is. Are you guys pretty familiar with factoring?
Yes.
Okay, I figured that. All right. So we're going to factor out what?
2x squared.
2x squared. So see, this is my taking out part. So I'm left with the x there minus what?
4.
4. All right. This is factored completely because there's nothing else I can do to it. Right? So that's a great example of taking something out right there. I took it out. I can't do anything more, so I'm done with this. And it's factored completely. We're still factoring completely. Let's try 3x squared minus 27. Okay. So, again, I'm going to ask myself, can I take anything out of that?
Yes. 3.
When I take 3 out, what am I left with?
X squared minus 9.
Now this, right?
2 squared.
Difference of two squares. Okay? Because you have a square here, and 9 is a perfect square. Okay? All right. So here's when we have to factor completely. You wouldn't want to leave it like that. The 3 is just going to come outside. And what are we going to have left over on the inside here?
X minus 3, x plus 3.
Yep. There we go. All right. Done. So that's a difference of two squares. Okay, so the x squared, that's a key to it. You might recognizing it, a minus. And then that 9 is a perfect square. Okay, 3 times 3 gives you 9. So there's a difference of two squares. Okay, what about, let's do one like this. What kind's that one?
Trinomial.
Yep. How come it's trinomial?
It's got 3 terms.
3 terms. Okay. So most of the time when you see something like this, you're going to think trinomial. All right. So how do you factor a trinomial? What do we do there? What's the general idea?
You break the middle term up, right?
So I would take, this is how I do it, I would take this number and find factors of it. 2 and 6, 3 and 4, 1 and 12.
2 and 6.
Okay. Now when I teach it, I always say, this is a negative, so you bring that with you. That cues you to tell you, these got to subtract to that, right? I'm probably not the only one that's ever done that, but that tells you what they're going to subtract to the 4. So which one subtract to the 4?
You want negative 6. So x squared minus 6x.
No, you don't have to do that. I know what you're thinking, but you don't have
Okay,
to.
sorry, yeah.
So we just got to go x and x, right?
Right.
And we know it's 6 and 2 because that subtracts the 4. And what's going to happen here? Which one's negative? 6, right? Because you need a negative 4, right?
Right.
Okay. Okay, so that's a trinomial. That's one type of trinomial. These ones I always have to think about when I have to make them up.
So, yeah.
Yeah.
The factor you use has to add up to the middle term, right? So in this case, we're using negative 2 and positive 6.
That's how you think about it, but yes, you're correct. If I put a minus there, because that cues me that they're actually going to subtract to that middle number rather than add to that middle number. Okay, so 2 and 6 are the ones that defer to 4, so that's the ones I'm going to use. And you don't have to do it. You can think of it the other ways. Then you would have to think of the 2 or the 6 being negative. Okay, so it all kind of depends on how you think of it, how you were probably taught it. Okay. What about this one?
5 times by 3.
Ooh. That would be the AC method. Nice. Okay. So that would give me 30. Now I got to find factors, right?
How did we get to 30?
Because somebody, was it
Well,
Bree?
right, but why?
Bree said, well, hold on. There's 2 ways to factor these. Okay? The one method's called the AC method, and that's what she's using. AC method because this is the A, B, C, talking about the coefficients of this.
Okay, no, I understand what that is now.
Isn't that what you did on the top, that other one as well?
No.
Just 1 and...
You'll see the difference. Okay? So, which one of these factors is going to give me the negative 1x that I need?
-6.
Okay. So if you're going to use the AC method, then you're going to go 3x squared, 5x, 6x, and 10. And this is going to be minus, and that's got to be plus because you told me. Okay, what can we take out of the first 2 there? That leaves me with how much?
3x plus 5.
Can't you switch them?
Yeah, you can. Doesn't make...
We do the 3 and the 6.
Yeah, you can do it that way. What do we want to take out of this one?
2.
Make sure you take a negative, though. Oops. So x minus 2 and 3x plus 5 is the answer, correct?
Yeah.
Okay. That is the AC method. All right? And there's nothing wrong with it. But if you're going to take more mathematics, you're going to be a lot better, you're going to be better served by using kind of a guess method on it. Okay, it's just going to take you less time. So in this method, right, I'm looking to see, well, I know these two guys got to multiply to 3, so what kind of factors could that be? 3 and 1, right? So now I just got to get my factors of 10. So I know I either have 1 and 10 or 2 and 5. 10's pretty big, and I need a 1, so I don't think that's going to work. So let's try 2 and 5. So I'm just going to put here. Okay, I know I got to have a negative. 3 times 5, what's that give me? 15, and this gives me 2. So 15, 2, that doesn't give me the 1 I want. So I'm going to switch this around. That gives me 5, and this gives me 6, right? So that's the ones I want, because 6 minus 5 gives me the 1 I need. Okay, so that means I'm going to make, let's see, I want the 5 to be positive, and I want that to be negative. There we go. Hey, that's just what I got up top. Okay. So there's 2 ways of doing those.
Are you gonna knock us down for using the AC method?
I'm not going to knock you down for using the AC method. I love the AC method, but if you're going to be factoring things in calculus, you're not going to want to use the AC method. Okay, I'm just telling you, honestly. All right, nobody's ever going to knock you down for it. But only 10% of the polynomials in the world can be factored anyway. But yeah, you spent all kinds of time factoring Math 65.
We spent half a term factoring
Yeah,
by groups.
yeah, but only 10% of the polynomials in the world can be factored. Oh, okay. And those T89s you have, they'll factor all this stuff for you.
Nice.
You gonna show us how?
No.
Did you read the book?
Would that not do it?
No. Sorry.
You can get a math link and then punch the problem in and then factor by grouping, and they'll give you the answer, but they won't show you how you got it.
Yep, it's out there. You want to try another one like that? Then take a break? Yeah. 4x squared. Takes me, I guess you gotta figure out, let's see, let's go with 9, that'd be 36. 12 plus 15. X. There we go. Let's try one like this. So, you want to do an AC method or guess method? Oh man.
I want to see the guess method.
We'll do it both ways. AC method, so that's going to be 36. Plus or minus, what would that be? Plus. So we got to find factors of 36. And the AC method is good too, except if you get a number like 288, you're going to have a lot of factors. 4 and 9, 1 and 36, 2 and 18, 3 and 12. Did we find it yet? Okay. Did anybody ever show you that? Probably they did. But if you start with 4 and 9 and you have that and double that, that's going to be a factor. Anybody ever show you guys that? All right. If you start with 4 and you have a 4 and a 9, an even number here, if you have it and double that, that will also be a factor. See, 6 and 6 will also be a factor. Double 3 and half 12 works every time. There's also a way to do it on your calculator. It's pretty slick too. Okay, which ones work?
3 and 12.
3 and 12 is the winner. What do we write?
Doesn't matter. You can do plus 3 plus 12. Doesn't matter.
So I'm going to go 4x squared, right?
Yep.
Plus 3 you want, plus 12, plus 9. Group. This is factoring by grouping, by the way. We didn't even cover that one, but that's what this is. So what can you take out of the first one?
X.
X. 4x plus 3. What can we take out of the other one? 3. 4x plus 3. And somebody probably told you that if these two things are wrong, then something, you didn't make a mistake someplace. So these two got to be identical, or else it doesn't work. Okay, there's my answer. Okay, so for this one, here, yeah.
I had a question about the problem you just did. So, factoring those by grouping is how I learned in 65.
Yep.
But I just have a question. So, once we found the factors of 3 and 12,
Yep.
and you substituted those for the middle term,
Yep.
the middle term is only 15x,
Mm-hmm.
but yet it becomes 3x plus 12x. Where did that second x come from?
You're foiling. So if you were to foil this answer we got, right? That gives you 4x squared, so that's that. X times 3 is 3x.
Right.
3 times 4 is 12x, and 3 times 3 is 9.
Okay.
So this, you're really walking backwards on the foil when you do it by grouping in the AC method. Did they not show you how to do it the other way? Did they all do them AC method?
Yeah, the teachers don't really like, the 65 teacher that I had didn't really like the FOIL method.
Same here. Yeah.
Thought it was a waste of time and was only effective on binomials.
I would put the guess and try.
Well, I don't care which way you do it, but I'm saying that when if you take higher level mathematics and things get complicated, AC math is going to slow you down. Assuming they don't let you use some sort of technology to factor it on your, you know what I'm saying?
Yeah.
So, all right, let's give this a shot. So we need some factors of 4. So what could we put there in the beginning? What are some factors of 4? So I could put 2 and 2, okay? And so I need a 15, so I could go 9 and 1, but I'm going to go with the 3s and see if that does anything for me. So that gives me how much if I do that? 6 and 6 gives me 12. Rats, that doesn't work. I really don't think the 9 and the 1s are going to work very well, because when I multiply by 9 times 2, what am I going to get? 18. So you see, you kind of got to know a little bit about what this is going to look like when you do it this way. So I don't think, let's just go with this one here. Okay, now I'm going to try a 3 and 3 and see if that works. What does that give us?
12.
What does that give us?
3x.
Oh, hey, 12 and 3x, what does that add up to?
18.
There it is. There it is. Okay. So like I said, I don't really care which way you do it, but I think if you take more math, it's going to be better if you can kind of learn it this way. It just takes a little bit of time to get a feel for what you need number-wise there. Okay. Sorry to crush.
So you do like 3 times 4 plus 3. What's going on right now?
What's going?
To get to your 15.
3 times 4 is 12.
Yeah.
Foil in your head. 3 times 4 is 12, and 3 times x is 3x. That combines to 15. So you're just foiling. If you're good foilers, then you're probably able to see it this way.
Yeah.
Yeah. It's got to be good foilers. Here, I know this one. I bet you did a bunch of these. Did you do a bunch of those? Sum and difference of 2 cubes, and you had that crazy formula? Did you do those? This book loves that stuff. Or in that other book did? Man, these are terrible. I don't even do them. There we go. No, seriously, they're just not very good. The other guy teaches at our school. We don't even teach that stuff. You just don't. There's not much use for them. There's so much better ways of doing it. So, okay. Do you want to see a couple more, or you want to take a break? It's your call. Okay, take a break. See you in about 5-10 minutes. More interesting stuff. I'm going to pause it this time. Get rolling here, because I got some things I want to do. So factoring, let's see. I want to look and see which ones here we have to do in this section. I just want to make sure you're pretty comfortable, and I didn't give you any. 19 through 53, odd ones. Let's do this though. Don't do 41. Cross that one out, because that's one of those sum of difference of two cubes. And 43 is no good.
What about 21?
This is on 3.
21 is okay. This is on page 218. So 41 and 43 we're tossing because those are cubes and I don't like those. So everything else though is good. So do you see any there that 19 through 53 odd that right now if you looked at it you'd just go, I don't know how to do this at all? Is there one there that messes you up?
45, you would do them separately, correct?
Which one, 45?
45.
45 would look like, this is whenever you see 4 terms, that's a factor by grouping almost
Grouping, right? Okay.
automatically. So I would group this one, I'd group this one. And what would we take out of the first two?
The first two would be x cubed.
X to the third.
So that would leave me with x minus 2. And then what would I take out of the next one?
Nothing.
Right. But you can take a 1 out. You got to take something.
Oh, you do? Okay.
So you take a 1. And then when you do, since this is a plus, this has got to be a minus here. Does that make sense? Because you always drop that sign down. Okay?
Okay.
You can't take anything out of there, but you got to have something as a placeholder for this. So you just always take a 1
Okay.
when there's nothing that you can take out. So when you take that 1 out, you're kind of undistributing. So see how this would distribute and give you a +2?
Yeah.
So that's why that becomes a negative, because it has to be the same. So you're undistributing there.
Okay.
And then your answer is going to look like this, okay? But in the back of the book, they're going to have you break that x cubed minus 1, but we're just going to leave them. We'll just leave it, okay? So 4 terms are almost always factoring by grouping. Any other ones on there you would look at now and not sure exactly?
So would 47 be r squared plus 2?
That's a difference of 2 squares, right? So what's the square root of 16?
4.
So you get r squared plus 4 and r squared
Right.
minus 4, but this is still a difference of 2 squares.
Oh, that's true.
So you want to make sure you're factoring that completely. That would be one where, you know, people tend to make mistakes on that. And don't factor it completely. Okay? See, I'll probably put something like that on the test and somebody will get it wrong and I'll go, wow, gosh, I feel bad, but I told them that factored completely. All right. I mean, that's what happens. Any other ones on there? Okay. So what I want to do is go to the next section, which is solving quadratics. Okay. But I want to talk a little bit about that. So on solving quadratics, you did some of this in, I think it's in 65. Yeah, it is. And here's the ways you do this. One, you can graph them, which is what I want to take a look at. Okay. The other way is to use the zero product property, which is what it's called. And that's factoring. And the other way, and I know you know, I'm pretty sure they cover this, but it's all covered in this in the very end. And that's called the quadratic formula. I think they cover that.
Yeah.
So it's kind of weird that they have you solve quadratics in this section, but they don't want you to do it by the quadratic, at least they don't mention the quadratic formula until the end of the course. And then they say, they review the quadratic formula again. Okay? So, as far as I'm concerned, it says to solve it. I really don't care which way you do it. If you want to use the quadratic formula, you can. But I think all these can be factored. So, you can use the zero product property also. Alright, here's what I want to focus on, and then we'll solve some of these. I want to talk about graphing. So have your calculators and your Desmos ready to roll. Okay, so we're going to take a look at y equals x squared minus x minus 6. And we're going to graph that. So let me pull up this guy. I'll go back to it. There we go. Where's that? Right there. There we go. Okay. I'll turn this guy on. Alright. So what we're going to do is I'm going to show you how to solve these graphingly. I'm going to show you how to solve any polynomials. I want to talk a little bit about what your activity is going to be so you'll have an idea about that. And we'll go from there and see where we end up. Hopefully I can get it all done in like 40 minutes. Alright, so let's graph this. So I'm going to graph it on the 89 first, and then I'll graph it on the Desmos. So let's see, I need diamond and y equals, and I'm going to get rid of that absolute value. I don't need it. X squared minus x minus 6. And maybe I'm repeating. I don't exactly, just don't know your whole background, so that's why I want to graph this. Okay, so all these quadratics are going to give us a U shape. Alright, so whenever you see an x squared, you're going to get some type of a U-shaped graph. Either it's going to open up or it's going to open down, and I can kind of show you where that comes in, but you're going to get a U-shape. Right. The answer to this, if we factored this, x, factors of 6 that would give us a negative 1, what would that have to be? What are factors of 6?
2 and 3.
Okay. So which one's going to be negative? Right. Alright. So if I set this equal to 0, then my answer is going to be, this is a zero product property in factoring, my answer is going to be what?
3 and negative 2.
Right. If I go back to the graph, okay, and I focus in on here, where does this thing cross the x-axis at? So that's where your answers are. So that's what they mean by graphing. Okay, so on the test, the question is going to be solve these and then verify your answer graphically. So again, I'm just keep going back to that verifying your answer graphically. So I think you should be able to look at the graph and say, oh, yeah, my answers jive there. That's good. Okay, there we go. Let's see. Are the Desmos people able to graph these okay and figure them out?
Yeah.
me keep doing it this way? Okay. It's real easy. All right, so that's that one. All right. Let's try another one here. So y equals 4y squared minus 16. I know I'm going to get a, so I'm going to type this in. Oh, I should have showed you, sorry. What if we don't know what that is and we want to find that answer? Here's how you do it. You go, where's it at? Math. So that would be F5. Okay, and when you go F5, this thing is called a 0. And the reason why it's called a 0 is because it's at that particular value, the function is 0. So we go down to 0. Okay, lower bound. Lower means left. We talked about that once. So I'm going to go find this first one here. So lower means left. So I'm going to use the little arrow keys. I don't know if you can see what I'm doing. I'm using the left arrow keys, and I'm going to go to the left of that 0. There. So I use this key to go to the left of that. Once I'm to the left of it, I press enter. Upper bound means I'm going to move to the right of it. So now I'm going to go to the right of that and press enter. And the answer is -2. So that's how you would find it. So then the problem is, oh, you got to do that again. Why the Desmos person's already got 3 problems done. Because it's a little bit more efficient. Lower bound means left. So I'm going to go to the left. Come on, get to the left of it. I just want to get kind of close. Upper bound means right. And it does actually put just a little tiny like arrowhead here to tell you where it was. Press enter. And 3. Okay? So that's how that works. 83s and 84s are very, very similar, except you go second and calc. I can't remember what that's above. Is there an 83 here? No. Trace. Okay, and it's 0 again, right?
Yeah.
And does it say left and right, or does it say upper and lower?
It says left bound.
Left bound and right bound. Okay. Yeah, they should have left that on for the 89. It makes more sense to do left bound, right bound. All right. So let's go and do this one now. Oh, diamond y equals, there it is. So I'm going to get rid of this guy. Going to put this in. I don't know why I put a y squared there. Why did I do that? There we go. So 4x squared minus 16. There. And graph it. And it's a U shape. Okay, it's just that you don't see it because you don't have a complete window for it, but it's a U shape. All right. So it looks like 2 and -2, and I can go find them. Let's go find them one more time just so we know how to do it. What button do we push on this? Good thing we're doing it. F5, right? And then what do I push? 0, somebody said it. Lower bound means left. Upper bound means right. So you're just basically surrounding that 0. That's how you do it. Lower bound means left. Upper bound means right. Come on. Where's it at? There it is. Oops. 2. Okay. If I wanted to do it symbolically, I'd probably follow my factoring rules, which would say, can I take anything out of that? Then I have a difference of 2 squares. Right? So there's my answers. Plus or minus 2. Okay. 4 doesn't mean anything, just sitting out front. Alright? So you're just going to factor these. I mean, that's what they want you to do with them. And they're trinomials, mainly. Some of them are differences of two squares. Alright? How about, negative 2x squared plus 10 equals 0 and minus x. Okay. So here, we'll graph this one up. Go up there and clear that out of there. Negative 2x squared minus x plus 10. Enter. Diamond graph. Now I have a U shape opening up downward. You know why it's opening up downward? Because the a value is negative. Very good. Okay. Now this one I can't really tell what it is, so I really would have to go and get it. Okay, so I would really have to go find the 0, see what it is, lower bound left, upper bound right. Desmos, you're just clicking on it. Done already. Negative 2.5. And do the same thing. Go get the other one. Is everybody seeing how we're doing this? If you're not, you gotta say something.
I don't know how to do it online.
What kind do you have?
84 plus.
I'll show you. Yep. Yep. Okay.
No, just all of them.
Oh, you just.
Use them all the time.
Oh, okay.
Okay, so if you wanted to use a quadratic formula, you could, right? There's your quadratic formula right there if you remember it. I don't know how much you were drilled at. And then A, B, C, and then you just plug it into the formula, right? So negative 1, so it'd be 1 plus or minus the square root. 1 squared is 1. 4 times negative 2. And I'm not going to do a whole lot with this because where?
No, because it's a negative b.
Because you're taking the opposite of b.
Cancel each other out.
Who was asking?
Oh, no, like then you have to square root because it's b squared minus 4a times 3.
Right, so
And
if
then
you take
you-
negative
when
1, you square it.
Yeah.
That's going to be 1. I always square it in my head. Okay. Again, I'm not going to be, Steph, you don't want to worry too much about this because you're going to do it at the very end of the term anyway. I was just setting it up because I know you probably have seen this and you might have asked why we wouldn't use the quadratic formula, so I thought, oh, we'll just do it. Yeah, me too. It works on every single one of them. That's what's good about it. Factoring, again, does not. And neither does graphing for that matter. Let's see, 1 plus or minus 81 over negative 4. 1 plus or minus 9 over negative 4. So we get negative 2/5 and 2. So we get the same thing that we got there. Okay. So, I mean, you can factor it. All these are going to factor, or you can use your graphing. Okay. What about one like this?
You walked me on that last one. You don't even know how to do that?
No,
Yeah.
not till the end of the year, end of the term.
Okay.
Yeah. So this was a cubic. There's no cubic formula. How would you solve it?
Moving.
Got to graph it. X to the third plus x squared minus x minus 6. Enter, diamond, graph. Okay, where's the answer at in general? Where it crosses just the x.
It only
Just
crosses
the x.
the x-axis once though, right?
Yep.
So it's just gonna be one number?
It's just going to be one number. Okay?
2?
Well, it looks like 2, doesn't it?
Yeah.
All right. It looks like it might be close to 2.
Yeah, it's almost 2.
Okay? So what I'm going to do is switch a little bit here. I'm going to go into this. All right. Oops, I just want to do that. Okay. So, I want to take a look at some of these cubics, and I want to take a look at some of these 4th degreers. Okay? Let's just enter them like this. Y equals. You can do this in your 89 too. Alright, let me get rid of this guy. Okay. So, I put plus 3 plus 1, x minus 2. Here is, it's in factored form. This is the shape. Alright, I'm going to write up here for a little bit. So, when we had a quadratic, oops. That is called a 2nd degree polynomial. Because, what's the highest power on it?
Squared. 2.
Squared. This one's a cubic. It's called a 3rd degree polynomial. Because what's the highest power on it? 3. Okay? These are going to look like this, or look like that, depending upon the first term, right? Okay? Cubics are going to look like that. Or like this, depending upon the first curve. So U's and N's. All right, I'm gonna add another one to this one. Now this doesn't look like much. I'm gonna put a small number out in front. What do we got now? A W. This is called a 4th degree polynomial, because what would be the highest power on it? 4. Yeah, there is. What do you think a 5th looks like?
Just another curve.
Another curve. So more like this, or like that?
It would just be another hump.
So you're going to get a lot of U type shapes on your even powers, and your odd powers are going to be more N type shapes. Okay? So what you're going to have, what I'm going to ask you to do in your activity is to use these polynomials and use what you know now about x-intercepts to design stuff. So let's say you wanted to make a block letter U, W. Like that. Okay? That's what we want to make. So we know these are the x-intercepts, and we have two curves. So let's do the outer curve first. We'll do the outer one here. Y equals parentheses. How many parentheses do we have? How many steps? Four. Very good. So how many x-intercepts do you have? Four. Okay. Give me a number for this. 7. Give me a number for that, or for this one. Well, wait a minute. This is 7, that's not going to be 5. 8, 10, 11, 14, 15, 17, 19. How you getting those? You're kind of guessing, right? Yeah. But, I mean, 7, 8, 10, you space it out by 2, 1, 10, 11. This one's by 3, so we'll see how symmetric it looks. 1, 2, and then 2. We'll see how symmetric it looks. Alright? So we're going to type that in. Now, you guys can type it and see what we get. Let's try it out. Alright, so I'm going to clear this out. You can use either calculator or whatever you have. It doesn't make any difference. It's all going to work the same. Y equals. Now, when you're dealing with these, I would recommend that you put a very small number out in front. I went with 0.1, so I'm going to try that again, because otherwise it's going to get shoot up and down like crazy and you're not going to be able to see it. So let's see, we have x. Would that be a plus 7 or a minus 7? What do you think it would be? Let's see what it does. Whoops, wait, minus.
Because it reverses, right?
It reverses, right. Okay, then what? Now, I'm kind of confused a little bit. We're making the outer one, right? So if I trace that in blue, it's here.
Oh, so it's like, okay, 11 maybe 14.
Okay. So 11, 14, and 19. So minus 11. X minus 14. And X minus, what is it? 19. Okay. Close this up. Let's see. There it is. There's our W. Okay. Do you like it? Dips down here a little bit. It's not real symmetric. Why was it not very symmetric? Remember what we said? What was the difference between 17 and 19 here? 2, but what's the difference in these two? 1. So if we look at that, see here we have a difference between 7 and 11 of 4, and between 4 and 19 we have a difference of 5. So maybe we should make that 19 something different. Let's try 18, see if that makes it a little bit more symmetric. Oh, that's nice. Look at that one. Okay. Now, 0.1 again. What do we want the other one to be? So x minus 8 and x what? Minus 10. And then x minus 15. and then x minus 17. That's not too bad. That looks pretty good. Looks pretty good. Okay, so let's see. I'm going to leave that alone, but I'm going to write on here because I want to let them know what we were trying to make there. Alright. So that's pretty good. You know what would be even better though? If we could tell this to stop drawing right here and stop drawing this blue one right here. If we could get it to stop drawing at that point, that would be really neat, wouldn't it? Okay, Desmos people, are you ready? We're going to tell it to stop drawing. So let's take the blue one. Alright? Oh, I just undid that. That was bad. I don't know if I can get that back. There we go. Alright. So let's take the blue one and let's stop drawing it someplace up in here. And that would be something after 6. Agreed? Because we have 5 here. Right? So it would be something a little bit after 6 or after 5. I'm not sure where it is yet. But I know that's where it's going to be. So I'm going to click up here. And I'm going to go all the way to the end. I'll show you how to do this on 89 too. And the other ones. And I'm also going to put some screenshots up and put it on the website so you guys can look at it if you forget. In Desmos, you go down here to the little ABC thing. And you find these little brackets here. They're little curly cues. And you push that. And then you're going to go X. And we want to start graphing that for numbers that are greater than 5.5. Alright? So that would be my one. So I'm going to stop, take a look at it, and see if it stopped it. Oh, it did stop it, but it didn't stop it to way up here. So maybe we should try something bigger. Let's try 6. See what that does. How does that look? It stopped it. Gosh dang it. So let's try 6.5. There we go. So now it's getting better to where we're stopping it from drawing. Okay? But I also want to stop it drawing over on the other side at some place around 19. So if I go over here, what if I went, would that be an and or an or problem, what do you think? Any ideas? Now we're thinking about, okay, so, alright. So let's try that. So if it's an and problem, then let's switch. Well, we want to draw it for x is greater than 6.5, but we want to stop it. So what if we went like this and went 6.5, 6.5, put our sign like this, put x, put this, and then put 19. That will definitely stop it. Now if I go a little less than that and go about 18.5, there it goes. And it's done. Okay? So if you use the little curly cues, you can stop this from graphing. That's called restricting the domain, because that's what you're doing. You're restricting the domain. On the other calculators, you can do the exact same thing. Alright, so what was that? 0.1 parentheses, what was it? X minus 7 parentheses x minus, what was it? 11 parentheses x minus 14 parentheses x minus 18 parentheses. All right, now, do you have a key that looks like that? Just a straight up and down thing on your 89s? Push it. That is called the such that key. So now you're going to put in the exact same thing that we did. So what was that number we had? Was it 6, 5? What was it that we picked? 6.5. Okay. Now I need those inequality, so I got to find them and see where they are. Let's see. I don't know if they're on here, but they are. I know where they are in the machine. I don't know if they're a key. We have to go to... Are they on there? I don't see them. Do you guys have them on your newer ones? The little less than, greater than signs? Oh yeah, there they are. So that would be second and 0. Sure doesn't look like it, but I know it is. Second and 0. And then I'm going to put an X. And I'm going to put second and 0 again. And then what was my large number? Was it 19 something? We used 18. Syntax? What do you mean?
You didn't close it.
Oh, I shouldn't have to close it. Is everybody in syntax error, or is he getting it to work? I might hit something wrong. Did you get it to work? 89 people, did you get it to work?
I can't get it to work on 84.
Oh, no, that's a whole different deal.
Yeah.
I'll show you what that one is. But the 89ers get it to work?
I'm gonna raise your hands for her. That's fine, I'll figure it out.
Did it not work?
I don't think I know.
I think I probably pushed a button there and it might have messed it up. But that's how you put it in. That little such that key is the thing that does it. On 84.
Yeah.
It's gonna look. So you're gonna do the same thing. Y equals 0.1. Okay. All it's gonna be the same. And this is gonna seem weird. You're gonna go divided by. Parentheses. What was the small number? 6.5. And
I don't remember.
you don't know where what is?
I don't remember.
Oh, that's 6.5, I think. Then you need, you see where it says test? I think it's in little letters. Push that. And that's where your signs are, right? Your inequality signs are in the test.
Yeah.
X. And then try doing the same thing and going, I think it was 18.5. See if that works. Did it work? If it didn't, then we have to try something else. That's how you do it on there, but you have to put division. I don't know why, it's just weird. Yeah. Okay. It worked?
Yeah.
Sweet.
Skewed, but it worked.
Good. So what I'm going to try to do is just take some pictures of each syntax and post it on the DDL for your calculator and for Desmo, so you can follow that, so you'll be able to go and say, okay, here's an example of how he did that. All right, so you'll have that when you do it. All right. But that was the main thing with the polynomials, is just the different shapes. So it's kind of a neat how they work. But in the assignment, we just had to solve those. So any questions on the assignment part? Factoring, solving them? Any questions on the test Wednesday from that guide? If you didn't get one, they're right there.
So the homework for 326 and 327 isn't due till next week?
It's not due till Monday.
Is it gonna be on the test?
Okay. It's gonna be on the test.
So I would look some over. You look in the guide, okay? The guide will tell you what you're going to have to do.
Do you have answers for the sample test?
That's what I was gonna ask. Oh, is there an answer key so we do know?
Is that what you want?
What is the activity?
And I won't know if I'm doing it right or not.
Yeah, when do you want it? Not a lot of time.
No, no. Wednesday noon.
I can try to put them up there tomorrow. I'm handing out the activity thing to you. Now this isn't due for a whole week, so, right? Set it on here. Activity, right? Tuesday. Right, so that's not for a whole week. You have some time to work on it. Yep.
Oh, yeah.
We don't have a quiz today.
Yay.
I canceled it when you guys asked a bunch of questions. Oh, we were gonna run out of time. Yeah, I want to answer a question about anything else, so I'll hang out.
We're supposed to, this equation, we're supposed to build the equation like this.
Yeah, like the M that we did with W, but it's just an M, right?
Right, so it's just negative.
So you're just gonna screenshot, so yeah.
Someone, the first one that made it all.
There's three. Yeah. But it's not an assignment, right? Don't turn it in. It's just a guide.
You're gonna put the.
Hey, that was a good comment that you made.
Thank you.
And I never really thought about that before, so I want to take that and think
No,
about
I
that.
appreciate that.
No, I'm glad you made that comment.
That's like, there's no way I can get this all done in one
No,
night.
you don't.
I
Yeah.
work, you know.
Right. No,
So,
I'm
yeah.
glad you. So, Ron, what I'll try to do is just make it, and I was trying to just say to you basically, you know, if you got a kind of a feel for what we do,
Right.
I think you'll be okay without having to do the whole thing. So I get what you're saying.
Yeah, well, and the thing that I'm running into is I'm not having any problems with the math really, other than little scripts here and there. The damn calculator though, I cannot figure it out. I cannot, to save my life, figure out the stupid
That's the
calculator.
89.
Yeah, so every time that we have one where the answer needs to be graphed, or the answer needs, you know, I need to use the calculator to do it, I'm just screwed. I'm like throwing up my hands going, I am not gonna pass this class. That's cool, that's yeah, yeah, and for some things we can do that, but for others it's like, you know, what am I, you know, I don't know.
How much math did I take?
Yeah, gotta take 9/11, 112. So I have to learn how to use it. Yeah.
Wow. Let's just tell you what. Let's do this. I would use your decimal for now,
Yeah.
and then we'll kind of just gradually get you going on the design, and hopefully
Yeah,
by the end.
I've got little bits, like I can add and graph something out, but if you put the how to limit the domain on this, there's gonna be a
I can already feel
on
I'm
the
gonna put it on there.
Okay.
Yeah,
Yeah, I
I'm just
think
gonna
that'll help.
I'm just basically gonna show how to do it, write it out by this, and then I'll put it in the document, show the end, and then take a screenshot, a picture of it, and put it up there so that you can look at it.
Yeah, all the YouTubes that I can find, you can either see the keys or you can see the screen. But you can't see what they're doing at the same time. So it's like, which key did you punch? I don't know. And that's
Sure.
I can like study a lot, but I have a problem with like book study exam. Do you know any like study techniques so I don't like